In this part of the question, we are asked to find the total downwards force acting on the bottom acrobat. In order to do this, we will work out the force on the top acrobat, and then the middle acrobat, and finally the bottom acrobat. Let's start with the top acrobat. We know that there are only two forces acting on this acrobat: his weight, mg, and the reaction force from the middle acrobat, which we found in the last part of the question. It was equal to mg. Now let's consider the middle acrobat. There are three forces acting on him: his weight, mg, the reaction force from the top acrobat, which is equal and opposite to the one we worked out in the last part of the question, and the reaction force from the bottom acrobat, n. For this acrobat to be in equilibrium, the resultant force acting on them has to be 0. Therefore, we can write down that R plus mg equals n, since the downwards acting forces must balance out with the upwards acting force. Therefore, n equals 2mg. Finally, we can consider the forces acting on the bottom acrobat. Once again, there is his weight. There is also the reaction force from the middle acrobat. Again, this is equal and opposite to the reaction force we found in the last part of the question, which was acting on the middle acrobat from the bottom acrobat. Finally, there is the reaction force from the ground, which acts upwards on the bottom acrobat. Here I have called it F. The total downwards force here is the sum of n and mg, his weight. Now we have the total downwards force acting on the bottom acrobat in terms of m.